Lab Experiment 1 consisted of testing a model of constant velocity versus a real-world experiment. The lab experiment in the world was performed by rolling a spherical ball across a flat table and measuring time and position data via the program tracker. The point of the experiment was to examine Newton's first law. In an ideal situation where no net force acted upon the ball once it started rolling, it would have continued to roll across the table at the same velocity and direction. This is due to Newton's first law, which dictates that an object in motion will stay in motion with the same direction and speed unless acted upon by a net force. The real-world experiment was also recreated within a code designed to output position and time data in order to compare to the real-world data. The main result of this lab was that the real-world experiment yielded decreasing speed due to some net force acting upon the ball. In the real-world experiment, a ball was rolled horizontally across the table. The coordinate axis assigned in this experiment was a horizontal x-axis with the origin at the starting point of the ball and the left direction assigned as a negative and the right as positive. The y-axis was designated as a positive being vertically up and the negative being down. The z-axis was designated as positive coming out of the screen and negative as going into the screen. The distance along the axes was calibrated using the known diameter of the ball, and time was determined by the frame rate of the video, which was 30 frames per second, or 1 frame every 30th of a second. The GlowScript model was designed to match this with the same coordinate system with the animated ball also rolling to the left, and the code measured the position every 1/30th of a second to match the frame rate of the experiment. Here is the real-world experiment being performed. Note the moving center of mass used to determine the ball's position in each consecutive frame. Here is the code and simulation running to replicate the experiment. Note that while this code runs much faster than the real experiment, the ball's position is measured through an equation meant to note the position at the same time interval as the real experiment. In order for the code to match the initial conditions of the real-world experiment, changes were implemented into the code. Tracker labeled the ball's initial x position as negative 0.003 meters, and so the initial position of the ball in the code was noted as negative 0.003 meters in the x direction, 0 meters in the y direction, and 0 meters in the z direction. The next change was the change in time between position measurements. Because Tracker measured the position every frame, or 1/30th of a second, delta t was input as 1/30th, or 0.0333. Here you see the net force in this experiment was expected to be 0, in line with Newton's first law. Tracker noted that the change in position within the first frame was negative 0.025 meters, and so in the model with no net force, it would consistently decrease by 0.025 meters every frame, since the law dictates a constant velocity, and velocity is changed in position over time. This was input into the position update formula in line 60. No other changes were made. Looking at the graph of the positions over time of the real ball versus simulated ball, it is obvious that there was some other force that influenced the real ball. This was determined by the inconsistent slope of the real ball's position over time. Newton's first law dictates that if the ball had had no net force, the velocity, which can be defined as the slope of a position versus time graph, would have been consistent on the graph like the simulated ball. Because the slope becomes less negative, the velocity becomes less negative with a smaller magnitude. It can be determined from this that there was a net force acting on the ball, and it was in the positive direction, because it opposes the negative velocity and decreases its magnitude. Taking what is known about the surroundings in the experiment, it is most likely that the net force came from a force of friction with the air and the table, which would point opposite the velocity. Inconsistencies between the model and real data might also have come from slight imperfections in the ball used in the experiment, or differences in rounding in Tracker, Excel, and GlowScript. In conclusion, the trend of both lines are similarly decreasing, just at different rates. The model perfectly demonstrates Newton's first law by excluding any outside forces contributing to a non-zero net force. The experiment run in a real environment shows an agreement with the first law as well, as its velocity does change due to a net force, as the law states it would. If the directions of the axes had been flipped, for example, if the x-axis had been labeled positive going to the left and negative going to the right instead of the opposite, then looking at this graph now, the trend would have been going upwards in the positive direction instead of in the negative y direction. Instead of the position getting more and more negative, the position would have been getting larger and larger in the positive direction. Besides getting rid of some negatives within the GlowScript code, nothing else would have changed.